I'm a student here in Durham, and I'm a generative AI researcher at the MITRE Corporation, and today I'm here to talk to you guys about generative AI observability. So my main goal in today's presentation is to impress upon you all the key relevance of generative AI observability. I'm sure a lot of you guys in your deployments or in your jobs have worked with these generative AI systems. However, observability has usually lagged behind the actual progress on developing generative AI writ large, meaning that we're having more and more generative AI systems with less and less observability to check back on it. So let's first talk about what generative AI observability is writ large. You've probably seen generative AI and a bunch of chatbots being deployed in all kinds of environments. If you go to any sales dealership website, or maybe like a car dealership, or even Amazon, there's probably some agentic or some small chatbot on the website that you can talk about. In that scenario, observability might not be the most important thing, since it's just telling a user where they can find a product or how to navigate to a page. But if we take a look at some more mission-critical examples, such as if we're using generative AI in things like healthcare, telling a surgeon what surgery to perform, or if we're using generative AI in something like finance predictions, those are two scenarios where accuracy and efficiency, i.e. the latency of the generative AI system, are very, very important. So that's where we need to implement an observability framework to better optimize these results and figure out how accurate and how latent your system is. So you might be asking yourselves, why have these products not already existed? Well, some of them have tried, but they all encounter a couple of key problems. The first is that their models are very, very complex, especially when working with generative AI models and natural language processing. It's very difficult to kind of get the behind-the-scenes parameters inside of these models and how these models are doing their probabilistic outputs. A lot of generative AI monitoring and observability frameworks struggle with doing this. Second is a lack of available data, especially if you're deploying your generative AI system to a user base that it's not been trained on. There's often a lack of good data or ground truth data for comparisons. And then, of course, when you're deploying into a new environment, there are always going to be a lot of problems that you can't predict with users or new edge cases in deployment that might come up with a lot of issues. So with these issues, you've probably seen a lot of papers online, whether it's from OpenAI or places like Anthropic, about their redlining teams, where they find these places where sending a prompt into a chatbot can generate a potentially nefarious or malicious answer. And that's really problematic. Again, we're optimizing for things like accuracy and things like efficiency, and that's where observability really has a key role. There are a couple of essential metrics that are key to observability. For the sake of this 5-minute presentation, I'll focus on the 3 key ones: output coherence, accuracy, and latency. If you've ever worked with machine learning or deep learning models before, you're probably familiar with the concept of coherence. You've probably worked with coherence in both the coherence of your input data and coherence of the testing, basically how logical and how correct and how much of the training or data actually makes sense. In the sense of generative AI models and observing them, the output coherence is how much the output is actually semantically relevant and is it logical following the data it's been trained on and following the query that we've queried this generative AI system with. The second is accuracy. Accuracy is actually really, really interesting because there's no real good industry metric to single-handedly evaluate the accuracy of a generative AI model. However, a lot of things have been made, things like frameworks like RAGAS or ARES for retrieval augmented generation system evaluation, if you ever work with that, and they have these custom math formulas that they've made to evaluate whether or not an answer is correct given the query, the ground truth, and some of these other values. A lot of companies I know of are actually implementing their own custom evaluator models just to judge if their generative AI system is accurate or not. And lastly is latency, especially if you're deploying a generative AI model on the edge or something again like finance where you need to make split-second decisions that need to be correct. A lot of the time, latency is a really big issue on how fast can we get these decisions made. So like I said, there are a couple of generative AI tools that are already in existence. These are things like middleware and like Dynachunk. However, the problem with these systems is they don't take an LLM ops approach. A lot of these systems take a DevOps approach that is being applied to LLM operations. However, if you want a more LLM ops integrated approach, a lot of the time you're going to have to be building your own custom framework because you want to optimize for things like tracing and input data and a lot of these more LLM specific metrics. That's why I'm here to recommend frameworks that are not just DevOps frameworks applied to LLM ops. Rather, your companies should probably be looking to implement things like RAGAS or ARES, which are both Python libraries that allow for dynamic optimization, which allow for dynamic evaluation of your generative AI frameworks. RAGAS, for example, I've worked with previously, and it's basically just a Python package you import. You feed it data from your ground truth, your context, and your actual LLM-generated answer, and you're able to evaluate the efficacy, i.e. the accuracy, of your language model. Like I talked about, there's no single one great metric to evaluate how a language model performs. That's why these very packages, such as RAGAS, have actually actually developed over 9 different metrics of their own. So that what that means is that each package, each company you work with, each language model deployment you work with is going to be a little bit different on how you're able to observe its accuracy, how you're able to observe its output coherence, and how you're able to observe its latency. A couple of key things arise from all these different tools that are already on the market. You can see some of them on the right-hand side of this slide. However, the key points is that you're able to have a dashboard where both technical developers and non-technical users alike are going to be able to understand what's happening behind this LLM, how it's performing, and how it's performing in the test cases that we need it to work well in. We also can see end-to-end performance analytics. That's things like, oh, how is the chunking doing in relation to controlling accuracy? And, oh, how is the embedding working? And when we actually generate, does changing the LLM behind the system actually have a big, big difference? So the key with observability is, depending on whatever framework you work with, you need to be able to ensure that your framework is accessible to both technical people and non-technical people alike. And with that, you're able to optimize for the metrics that you care about. Again, the metrics that you care about might not be the same as somebody else. Your company or your deployment might specifically need accuracy a lot more than they care about how latent or how long it takes the language model to generate a response. So the implementations will vary case by case. So I've talked about LLM ops a lot and why LLM ops is important. So a lot of the issue with current evaluation frameworks is that, again, they're just DevOps frameworks that are pushed into the LLM space. What that means is they don't control for these very specific metrics that you want to evaluate in large language models. Things like answer correctness, context recall, and other things like, oh, can we trace the actual LLM back to the, or can we trace like the LLM or maybe the augmented system to the data that it's generating this response from to make sure that it's not doing things like hallucinating up false responses, right? So that's the problem with a lot of these current evaluation frameworks out there. So what I'm advocating for is when you're out there building an LLM, whenever you create a new LLM framework for your organization, you ought to prioritize observability. A key issue on why LLM observability is so not great right now is because developers and researchers alike are just running forward with developing the next more powerful LLM, getting the next bigger amount of GPUs, and getting the next more accurate LLM. Post any of that, without any actual evaluation frameworks or observability frameworks, we're not able to have a great vision on how we can see how the LLM is performing, if it's being transparent, if it's being secure, if it's being accurate, and if it's being efficient. So some key takeaways from today's presentation is that first off, generative AI observability is really important when we're deploying a generative AI system. In fact, I would argue that observability is probably the most important aspect of a system because it's able to tell you how the system is performing, not just the fact that you have a chatbot, but you know your chatbot is effective. Second, I've introduced some key metrics for monitoring. That's things like how we can measure the latency, the accuracy, and the efficiency. Then I've talked about some advanced tools for real-time monitoring, but my greatest suggestion is that when you build your own LLM ops framework, prioritize observability. Use some of the libraries software that I've recommended, and don't go to a third-party vendor. If you can build your own specific to your use case, that's going to be where the money's really at. Thank you. My LinkedIn is Richard Shan. You can find me there, and my email is on this slide. I hope you have a great rest of the conference.